How Do You Know What Time It Is? By Robert E. Wells. Time is a mystery. You can't see it. You can't hear it. You can't catch it in a net and put it in a jar. But you know time is real because you can sense it passing by. In a way, time is like the wind. You can't see the wind, but you can see what happens when it blows. Kites fly in the air, clouds move across the sky, and boats sail over the water. And you can see what happens when time passes. Blossoms turn into apples, cubs grow into bears, and caterpillars become butterflies. But time is more mysterious than the wind. It's so mysterious that even the greatest thinkers and scientists can't say exactly what it is. Not with a measuring tape, of course. That's what you use to measure an alligator. A clock can measure time, but once there were no clocks. Long ago, people measured time with the sun. By observing the sun's positions as it moved across the sky, early people could tell how much time they had to gather food or firewood before darkness returned. Our ancestors didn't know why the sun kept appearing and disappearing. They didn't understand, as we do today, that Earth is round and turns like a top, so that the world is light where it faces the sun and dark where it faces away. After a while, people invented simple time measuring devices. Egyptians made shadow sticks. As the sun moved across the sky, the stick's shadow moved around the stone markers. At night, they used water clocks. Water dripped from one pot to another pot with marks inside to measure time. Egyptians were among the first to divide time into hours. In Europe, sundials measured hours more accurately than shadow sticks, and sand glasses measured time with falling sand. By the 1300s, the mechanical clocks measured time with weights and gears. Falling weight turns clock gears. Escapement device rocks back and forth, allowing gear to move one tooth at a time. Early clocks only had hour hands. They could not measure minutes accurately. Later, pendulums were added. Each swing of pendulum allows gear to move one tooth at a time. When a pendulum swings back and forth, its regular rhythm controls a clock's speed. With pendulums, clocks can measure minutes and even seconds. Today, quartz crystals make even small timepieces more accurate than the best pendulum clocks. Atomic clocks now keeps Earth's official time. While the sun helped early people measure a day, the moon's changing shape helped them keep track of months. In Egypt, the regular flooding of the Nile River was very important because the water brought new soil to the fields. Egyptians began to keep track of the time between new moons to help them predict when the next flood would come. Long ago, people didn't know why the moon changed shape. Today we know why. As the moon orbits or travels around Earth, it's always half lit by our sun, as shown. But from Earth, we see that the light from different angles, causing the different shapes. It takes about 29.5 days for the moon to change. Through all its shapes as it orbits once around the Earth. We call that the moon cycle. The Egyptians saw that the 12 moon cycles passed between each flood. They made lunar calendars dividing 12 moon cycles into 3 seasons: flooding, planting, harvesting. But they soon discovered they had extra days to the calendars because 12 moon cycles are 11 days shorter than the cycle of seasons, or 1 year. The Egyptians didn't know why the moon cycles didn't match the seasons. Today we know that our seasons are not measured by the moon, but by the Earth's orbit of the sun. As the Earth travels around the sun, it revolves on an imaginary line called an axis. Earth's axis is tipped at an angle. This causes the Earth that's tipped toward the sun to be warmer and the part that's tipped away to be cooler. The changing amount of sunlight causes the changes in our seasons. It takes about 365.5 days for Earth to orbit the sun. We call that a solar year. Later, the Egyptians began to use a solar calendar. They knew that the star Sirius always made its first appearance in the morning sky, just before the floods. So they chose that day to begin each year. Since Sirius is in this position only once during Earth's orbit, the new calendar measured the new year at 365 days, just quarter of a day short. During the rule of Julius Caesar, the Romans began using the Egyptian solar calendar. In 446 BCE, Caesar added a leap year day to February every 4th year to account for the extra quarter day. The ancient Roman calendar, with only minor adjustments and changes over the year, is the one most of the world uses now. It's off by only 26 seconds a year. Today, our calendar is almost perfect, and with atomic clocks we can know the exact time anywhere on Earth. But because it's daytime on one side of the Earth while it's nighttime on the other, it would be confusing if clocks around the time showed the same time. Some people would be eating lunch in the dark. To solve that problem, our world has been divided into 24 time zones, 1 hour apart and centered on meridian lines. With time zones, it's not the same time for everyone. Time zones usually follow the meridian lines, but sometimes zigzag around cities or countries to avoid dividing them. If you straddle the line dividing 2 zones, it could be 9 a.m. for your right foot and 10 a.m. for your left foot. And if you're in Los Angeles at 9 p.m., you'd better not call a friend in New York for a chat. It's midnight there. Have you ever dreamed of being a time traveler? Surprise! You already are. Everyone on Earth is traveling on the path of time. The past is right behind us and the future is just ahead. Now is always exactly where we are. Instamatic time travel service. So far, no one has figured out a way to go backward in time except in the movies. But if you could, what would you like to see? Most people don't think about time very often. But it's so important we couldn't do anything without it. Without time, nothing could move, not even a fraction of an inch. You couldn't even blink your eyes. No matter how fast you blinked, it would take a tiny bit of time. Without time passing, you couldn't play a computer game, or eat a bowl of ice cream, or paint a picture, or ski down a slope. How could you? All those things take time. Aren't we glad we have time?